Afternoon. My name is Mr. Royce. It's AP Statistics. It's Thursday, January 23rd.
Is it BC or?
And it's actually AD.
Really? What's that
Anno Domini. Anno.
I thought it was BCE now, or CE.
So we have a game.
I enjoy this lesson.
I'm kind of big into actuarial science because it includes statistics and calculus, things I teach. Oh, yes.
I think, isn't it proper to say BCE now?
Some people say before the Christian era for BC.
It's
Common
before
era,
common
common
era.
era.
Or before the Common Era, even better. So,
Even less Christian.
yeah, right, before the Common
Wait,
Era.
it wouldn't be B.
Wait, hold on. We got a lot of stuff to do today. So let's take a look at what's going on. Go ahead and draw a rectangle around this. They're giving us a probability distribution table. And here we get to practice what we did yesterday. You know, so let's find the expected value. We're going to do three things. We're going to find we're going to find the expected value, but we're also going to find the standard deviation of the random variable and also the variance of the random variable. So they're asking for one thing. We're going to find three.
Wow.
And so you might remember from yesterday that you take the payoff times the probability. The thing I like about actuarial science is that it prepares you for the real world. They use tables like this in actuarial science. Actuarial science is a science of selling insurance to people. Insurance is a game. When did we talk about insurance yesterday?
No, we talked
So
about
insurance
it in
is a
the fourth
game.
period.
So it's like you pay your premium. You might have car insurance. Your parents might have bought you car insurance. But let's say you are paying $100 a month. So that's what you pay to play. And then let's say you get into one car accident, then they might pay you $10 million. Maybe that happens 30% of the time. Let's say if there's 5 cars, in the car accident, it might be a pile up. Then they give you $20 million of the payout, and maybe like 20% of the time there's more than 10 cars. They'll give you $30 million. So it turns out that getting into a car accident and getting paid by the insurance company, that's a win. Even though it doesn't feel like a win. Losing the game would be where you don't get into a car accident and the insurance company gives you 0. So the reason we're studying game theory, expected value, it's because there's so many things in the real world that are essentially random games. Driving is a random process. You don't really know at the end of the day whether you're going to get into a car accident or not, but you pay to play this game. You pay for car insurance, and then you either win the game, which means you're in a car accident, they give you money, or you lose the game, which means you don't get into a car accident and you get no money whatsoever from the insurance company. You lost the game. You paid and you get 0 back. So please don't get into a car accident. Don't try to win the insurance game. Be happy to lose the car insurance game. Here we go. What's the expected value of the random variable? On your calculator, if you haven't already, please type in 10 times 0.3 plus $20 million happens 50% of the time, plus 30 million happens 20% of the time. Type that into your calculator. Tell me, what is the expected value of this random variable? Raise your hand when you found one other person in your group who agrees with your calculator result. What did you say, though?
We win. GFA.
Yeah. Oh my goodness.
No.
I accidentally hit, no, it's not you. I hit Chrome by accident.
Aww.
So
Oh, no.
now Chrome is gonna hit, well, maybe it didn't quite hit.
It might lag your Promethean board.
So you got 19, press 19, store M for mean. Expected value is the average winnings, the average expected winnings. So if you haven't already, press 19,
store.
the store arrow, which is right down here above on, and then alpha M. So sometimes the mean is like a long number, and you don't want to have to type it in over and over again. So when it comes to standard deviation, instead of having to type in 19 over and over again, or maybe 19.1733, whatever, to find the standard deviation, all we have to do, see, it's glitching. You know why it's glitching? Because it's trying to open Chrome out that shit.
That's what I said.
Oh, no.
It's gonna take like 20 minutes for it to save. So what you do, here, I'll
Do the 8-minute yoga.
That might be an idea right there.
fine. Oh, no, it's saving. So let's see if Chrome is actually open. Please don't open. We have until, what is it, period 6, we have until 2:04. As long as we start the yogurt day, pre-yogurt day activity by 1:55, 1:55, we should be fine. I'm gonna shoot for 1:54.
So we get
Well,
10 minutes?
We're getting an extra minute.
10
there.
minutes
So I
for
think
yogurt
that's all
day.
in.
Same dishes right there.
Mr. Royce, have you ever considered running for president?
Control. I have not. I've not.
Okay.
Wait, for president of Wheaton Academy?
Let's go time. Sure.
No, I don't
Jens
know.
keeps
President of
texting me.
anything.
See, Google Chrome is trying to open. It's trying to open. We're gonna force quit that thing before it ruins our lives.
I know. I'm like, Jens, chill, my dude. Oh.
Chrome is gone. Okay, so, woohoo! What are all these other, wow, I have a lot of
I
stuff
know,
open.
Jens said it.
Okay,
was his
friends,
favorite.
we're back. I hope. Saved. Now,
He invited me
so,
to go down this summer.
so please pause aside conversations
Santo.
up here.
Okay.
In the real world, you often can't use a TI-84, so don't be in your calculator on math print mode. Go to classic mode, type in square root, double left parentheses. We're gonna take 10 minus alpha m quantity squared times 0.3 plus 20 minus alpha m squared times 0.5
I think
plus
it's minus.
30 minus alpha m squared times 0.2 parentheses. And in case you're wondering whether mere mortals can actually type in all those parentheses in a single lifetime, look, I'm gonna demonstrate this for you 10, 20, 30. So 10 minus alpha m. What's the next thing that I should type? If you're gonna direct me on keystrokes, what would you direct me to type next?
Go to
Graham, go ahead. You can say things like left parentheses.
No idea.
You should say left parentheses.
Left parentheses.
We're typing in the standard deviation, using yesterday's standard deviation formula. Left parentheses,
Left parentheses, 20 minus m squared times, go back, 0.5.
keep going.
Keep going, all right, plus 30 minus m squared, times 0.2.
Close parentheses, so we have a standard deviation is 7. So we have found for part A, we found expected value, or the mean is 19. Standard deviation is 7, which means the variance, VAR, of the random variable has to be what? Raise your hand if you're reasonably sure you know the variance.
What's
Val,
It's either square root or square.
to get from standard deviation to variance, you square, so it's 49. To get from variance back to standard deviation, you take the square root. So we found all three, mean, standard deviation, and variance. Okay, so I found those three for part A. Would you please do part B on your own? Find expected value, standard deviation, and variance for this random variable you may begin. Please store your expected value in alpha m.
What did you get? Okay, so did I.
Are people getting 4.2 for the expected value?
Yes,
Yes.
Mr.
Okay.
Royce.
So the expected winnings are 4.2. Store that in M, then calculate standard deviation. Okay, please direct the rest of the calculator keystrokes for me. Katie, do you mind telling me what to type in next?
Plus 4 minus 4.2 squared.
So instead of 4.2, just say
Oh,
M,
minus
because
M.
we stored 4.2 in for M squared.
Squared times 0.4 plus 6 minus m squared times 0.2 plus 8 minus m squared times 0.1.
So close the parentheses. So again, in the real world, you often have to, they'll do standardized tests after you graduate from high school, where they don't let you use a graphing calculator and you have to use calculators that don't have math print. That's why I'm a big advocate of getting out of mode math print and going to mode classic, so that you can make sure that you can think through the parentheses logic. Okay, so we'll just go to 4 decimals. 8868, 1.8868, 1.8868, and then just press squared, just squared button, it'll square the answer, so the variance is 3.56. So this one's approximately wavy equals, but this is exactly 3.56. Any questions on how to calculate either expected value, standard deviation, or variance?
Why is it approximate?
Because I rounded the answer right here to 4 decimals. Yes, go ahead.
If you're on the actual AP test, if you were to like put equal sign, would we get counted off, do you think, or not?
Yeah, that's, I mean, if it were if it were an AP calculus test, yeah, they'd take on a 9-point problem, they'd take off a point for that, for attending to precision, but the standards are not that high on AP stats. Yeah, they're just not. So you would not get taken off. But we teach things,
Yeah, no, I get
we go beyond what's just on the test. We're going for.
You don't teach for the test.
So the
You teach for
variance is just
understanding.
standard deviation squared, right?
Correct.
Alright, cool.
Variance is, standard deviation squared is music to my ears. Yeah, so, let's see, I wonder if there's any students in class, students, I hope, wow, they're not letting people out of some of those Chinese cities, like the city of Wuhan, they're saying, no, we can't go anywhere. I hope none of our international students are stuck in Wuhan.
Uh-oh.
I mean, they're getting all excited about the virus, they say that virus doesn't, yeah, it's, like, there has to be close contact, I don't think it would spread very quickly. But I don't know what's really going on, so I just hope all you international students, I don't even know if you have the internet in China, but if you do, and you can hear me.
I think they do.
Well, the thing is,
They don't have Google.
Frodo told me that they often can't access the internet from China.
Probably because of like saying.
They don't have anything Google related, so they don't have YouTube or
They
like
have
Facebook.
Weibo, that's
It's
what
free
they have.
speech.
This is going on YouTube.
Yeah, they
We
don't
got
get
free
it.
speech.
So
and
that's
you guys
what I'm
don't.
saying, they're just not, it's like, it's gonna be rough to get caught up if you can't access
The
YouTube.
only thing they have is Weibo there.
Yeah, which
They
is all
can
like
get a
government
VPN
censored.
and it's fine.
All right, so,
Until the government's locking on their
but
door.
hopefully the cities will get opened up pretty soon. Now, let's go to number 8. Here's another gamble. You're gonna make an investment. Every time you invest something, you put money in and you hope to win, but you might lose.
I think you're gonna win on this one, Mr. Royce.
Well, the man buys a racehorse. It's not all about men, but this problem is about a man. Pays $20,000 to enter 2 races, so it's an expensive horse. He plans to sell the horse afterwards, hoping to make a profit. No guarantee though, if the horse wins both races, its value will get multiplied by 5 up to 100,000. If it wins only one of the 2 races, it's worth 50,000. If it loses both, now it's worth only 10,000, so that's a loss. Man believes, okay, so now let's tree diagram this to find out what the possibilities are. Because the first race, friends, let's go first race. Now, the way I think about this is that the first race will be either win or lose.
I
And
agree.
he thinks that, I mean, those are the only 2 possibilities. He thinks there's a 20% chance that it will win the first race, so 0.2, 0.8. And then if it wins the first race, the second race will be the lower half of the tree diagram. Second race will be either win or lose. It's kind of a binary thing. And
Bless you.
Thank you, thank you.
You're welcome.
Green Bay Packers quarterback Aaron Rodgers is on this podcast.
He won
That's
then
on
lost.
YouTube. It's on YouTube. He rejected Christianity because it's binary, because it's either or. It's like either you go to heaven or hell. He doesn't like that, and so he decided to reject Christianity. Poor guy. I feel bad for him. And I used to like the
What
Packers.
other choice did you have?
So
Didn't have God with
Wait,
it.
are you not a Packers fan anymore?
I'm
You're
still a
Bears fan?
Packers fan, but I just feel bad for Aaron Rodgers.
You're a Rodgers fan?
I was, until yesterday. Now, so its value will jump to 100,000. Now, friends, are these winnings independent? Like if he's winning the second race independent of whether you win the first race? Well, he believes there's a 20% chance to win the first, a 30% chance the second. So it doesn't matter whether you win the first one, there's a 30% chance of winning the second race, so 0.7. So you can tell that winning the second race is independent of winning the first race. Would you please use your knowledge of mathematics to fill in all 4 leaves?
Yes.
Yes.
0.14,
Yes.
0.24.
Now, I've learned some things about multiplying decimals over the years. I'm pretty sure 2 times 3 is 6, so it's gonna be 0.06, 0.14, 0.24, 7 times 8 is 56, so 0.56. So, these are the 4 possibilities. Now, we're going to define the random variable, and you get to decide, I mean, we're trying to find the expected profit. Do you want to define the random variable capital X as the profit or the payoff? The payoff will be, yeah, we kind of learned yesterday that it's a little safer to define X as a profit, because then we're subtracting the $20,000 fee for entering this game right up front. So it looks like there's 4 leaves. So we're gonna set up 5 columns in our distribution table for random variable X. This is a profit distribution, probability of capital X equaling lowercase x. It looks like the probabilities, the 4 outcomes, let's see. I mean, suppose he wins both races. Win both. How much profit will there be? Which, by the way, the probability of winning both is 0.06. We see that. And what did you say the profit would be?
80 grand.
Yeah, we're subtracting the 20,000 from the 100,000, so that's an $80,000 profit. And that happens 6% of the time. Now, it could be that he wins the first race only. Or this next leaf, the 3rd leaf, is win the second race only. And the 4th leaf corresponds to the real world situation of lose both races. So we can tell the probability of winning the first race only is 0.14. Got a little bit of a glitch there, sent you back. Don't have to shut down and restart, I hope. The probability of winning the second one is what? Or I should say the second one only, second race only.
0.24.
0.24. Losing both happens 56% of the time. Okay, what is the profit if you win only the first
I
race?
go with 50,000 or
30,000.
That's gonna be 50,000 minus 20,000 is 30,000. And winning the second only is another one of those win only one races situation. What is the profit if you lose both races?
Negative.
Yeah, it's a negative profit, it's a loss is what we call it. So now we're in a situation where we can calculate the expected profit. Notice the flow of the problem. Use a tree diagram to get a handle on the probabilities. Then we set up the probability distribution table for the random variable. Go ahead and use your calculator to find the expected profit. I'm gonna pause the camera while you're calculating that. This will help you decide whether or not you want to buy a racehorse
I will buy one.
for
Mr.
profit.
Will you buy one, Dan?
Of course.
You okay with that one?
Yeah. Just a little
Okay.
slow.
What'd you get?
10,600.
So please raise your hand if you found a fellow group member who agrees with your calculation
Oh, I
for
know
expected
I know
profit.
that you're wrong.
All right, Graham, you're
I
on.
know that you're wrong.
Got $10,600.
Yeah, 10,600 is not correct because it needs units. So Graham was correct in saying 10,600. Dollars is the expected profit. So we can put in sentence form the expected profit.
Good job, Dan.
The expected profit is $10,600. Any questions on how to find expected profit? They didn't ask for the standard deviation, but if they did, you wouldn't want to have to type in 10,600 4 times. Just store it in M so that you can do 80,000 minus m squared times 0.06 plus 30,000 minus m squared times 0.04. 30,000 minus m
Does
squared
A
times
stand
0.06,
for
and then
mean?
negative 10,000 minus m 20 squared times 0.56. Any questions on the racehorse problem?
Variables.
Isn't it interesting how when you turn the page, you realize that these are problems that we did already. We already found this standard deviation, didn't we? So we're gonna end up using this blank space for something else because of a printing snafu on the second handout. Please take out the second handout, the one called Random Variables Part 2 of 4. It's over there if you want the paper.
You define snafu.
Snafu.
Yeah.
Oh, is that an unfamiliar word? A
I don't know
snafu?
what snafu is.
Yeah, so it's kind of like a kerfuffle. I don't know
Oh,
what
what's a
kerfuffle is.
Can you explain the acronym to me?
Snafu. So,
Put an
yeah.
acronym.
I don't know if it's just like when things get, like when a wrench gets thrown into things
Oh, I got it.
and a snafu, it's like, you know, things didn't go quite right. There's some sort of,
Could the shape save it?
I would hope that whenever there's a snafu, that you would have the shape with you just in case it can help you get out of these. And that's a Calc BC thing. So take Calc BC to find out what the shape.
Calc BC jokes, we don't get it.
Right, so,
Should be good.
Got it explained.
friends, here we go. We are, oh, that's pre-yogurt day. For pre-yogurt day.
Wait, what
I'm so scared.
All right, here we go. Random variables, part 2 of 2. So let's dive into this one. So someone wants to have children. A couple plans to have children until they get a girl. We're just gonna keep having children until we get a girl. But there's limits to this plan. They agree that they will not have more than 3 children, assuming they're actually in control of all this, even if all are boys. So they're willing to give up on the dream of having a girl if they end up with 3 boys. Let's do a sideways Venn diagram of the tree. So like for first birth, assuming notice they're assuming that there's no infertility issues here. They will be able to actually give birth. So the first child is either a boy or girl. No childlessness going on here. Second child, if there's a boy there, if it's girl, there's a boy that keep going, either boy or girl. Stop on the girl, but if it's a boy, it's another boy. What did we do to deserve this? So we have 4 leaves, and you said it's equally likely, so it's a 50-50 chance every time, independent. Please fill in decimal form, the 4 leaves. 1/8 is 0.12, 0.125. When you're done, you can look at my leaves, see if we agree. And notice, so 0.125 happened twice, 0.25, 0.5. Now it says create a probability model for the number of children they might have. If you read the problem carefully, you'll be able to see what your let statement will be. Do not expect to get full credit unless you attach meaning to your random variable with a let statement. So here, X is going to represent, there in the wording of the problem, the number of children. So what is the domain of this particular random variable? What are the possible numbers of children that this plan,
I would go 1 to 3. Closed.
so like 1, 1.5, 1.75,
No,
1 to 3,
like XE thingy majigger. And that
in a square bracket.
1, 2, 3.
That would be all the real numbers from 1 to 3.
Not
So
like that.
instead of the
Not
square
like
bracket,
this.
you would just do 1, 2, 3 to get the domain.
No,
So
this
that
thing.
tells us that in our probability model, after we
That thing.
take care of the lowercase x and the probability capital X equals lowercase x, the possibilities are it's going to be either 1 child, 2 child, or 3 children. Sometimes students get a little flummoxed by this because they're saying, wait, there's 4 leaves, but only 3 boxes. How do we figure this out? Like, what's the probability that you end up, according to this plan, with only 1 child? Yeah, it's if you have 1 girl, it's 0.5. Will it ever happen that you have 2 children? Well, yeah, that's this leaf, 0.25. What on earth do we do for the probability of having exactly 3 children?
You add them
Two
together.
Add those 2 leaves together to get 0.25.
Then you
So
choose.
once again, tree diagram precedes the probability distribution. Now you can find the answer to part B. So take out your calculator, work out part B on your own. Expected number of children. Don't be surprised if you get a decimal. Averages, expected values are averages. They often come out to be decimals. Who's got it? Who's already calculated the expected number of children? Marcus.
1.75.
Yeah, so the answer would be 1.75
Children.
children is correct. Now, what if they want to answer a different question, like what's the expected number of boys? Okay, well that means we need a new random variable. Let's pick y. Let y represent the number of boys. Okay, what is the domain of y? Use the same tree diagram.
1, 2, 3.
No, the kitchen is 0, 2.
Yeah, we can't get 0 boys, that's just not gonna happen. I'm sorry, wait, you said 1, 2, 3, actually, no, it's not 1, 2, 3.
0.
It's 0, 1, 2, 3. So it is possible to get 0
You
boys.
said?
Yeah, so 0, 1, 2, or 3, lowercase x, probability of capital X equals lowercase x. Class, go ahead and fill in the table and do the calculation. Okay, 0 boys. Expected value of variable y. I think my last period class got something like 0.875, is that what you got?
Yep.
0.875, not children, it's
Boys.
boys. Right, any questions on this one? All right, so now in problem 13, we swing back to number of children, so we swing back to part B. Let's store that 1.75 into M, because we need to find the standard deviation of standard variable, of random variable X. So please complete problem 13 using your calculator in the store M sequence. All right, so this formula for standard deviation may have seemed intimidating yesterday, but you're getting some good practice with it. It's pretty straightforward. Those of you who typed this in and found a fellow group member who agrees with the answer, can you give me
I don't like it.
a standard deviation for the number of children? Lydia, do you have that typed in already?
0.829.
0.829, is that exact or rounded?
Exact.
It's exact. And the units on that?
We're gonna put it into
Yeah.
Boys, girls, or children?
Oh,
Children is correct. Any questions on this, or does anyone disagree? Does anyone agree?
oh wait, that's not exact.
Yeah, that's not
Sorry.
exact.
So it's approximate?
Yeah.
Okay, so maybe equals. Any questions on number 13? Yes?
Well, I just have one question. I'm not really sure. I mean, I get everything that's going on, but I don't really get at the top of these graphs, these charts, what the x and the p, x equals x means. Like that's, I don't know what does that represent?
Okay, so
Like those right there.
like the probability that the number of children equals 1 is 0.5, right?
Okay.
And the probability that the random variable is 2 is 0.25. The probability that the random variable takes on the value of 3 is 0.2.
So it's just a probability thing, and the x
So-
is just, the lowercase x is just a.
Lowercase x are the particular values of the random variable, and this is a list of particular values. So the lowercase x does represent the particular values. Capital X represents the actual value that it takes on.
Gotcha.
So particular, actual. So if the actual value is this particular value, then that probability is 0.5.
Okay.
Yeah. All right, so thanks for asking that. I'm sure you were not the only one who had that question. Further questions on this page? Now, here's the snafu. The snafu is on the next page. It doesn't say 22 contracts and all that stuff. So it's like the wrong thing got printed. So to fix that, I'd like you to, you don't have to copy this down. This is just, actually, this will feel like review. Go back to that other document that has a lot of blank space on it, and let's just write, just write, no, not the blank sheet of paper,
Number
but
9.
basically page 3 of the first handout. And just, this is problem 22 from the book. So this is, I mean, this is straight out of the book. Just write 22 contracts, but you don't have to write the whole thing. All you have to do is write the following. You believe, see, you're bidding for 2 contracts. Sometimes you might be in a real world situation where you have to decide whether or not to sign on the dotted line. Are you gonna sign the contract? Well, it turns out that, just write number 1 in the tree diagram. You believe the probability that you get this first contract is 0.8. So you either win the contract or you lose it. Like you're bidding, maybe your company is bidding for the contract to put in, let's say, new lights at Wheaton Academy. There's an 80% chance you get that. So it means 20% chance you lose it. Now, if you get contract 1, the probability of winning contract number 2 is different compared to if you lose contract 1. So here, winning the second one is not independent of winning the first one. It's because you've already got so many employees committed. And so why are they gonna wanna hire you to do this other job when you've already got your hands full with this first job? So if you get, then the probability that you also get contract 2 is 0.2. So it's a low probability that you end up getting both contracts. So 0.8. But if you do not get contract 1, they'll be like, what's wrong with you, you loser? You can't even get contract 1. So it's like probably getting contract 2 is a little bit better, but you know, you have this reputation for losing. So it's kind of hard. Would you please fill in the 4 leaves of this tree diagram? Fill in all 4 leaves. Maybe you did that already. Maybe you're like super fast at this and you're just waiting for me to get my act together.
Yep.
And then,
Pretty much.
what's the probability? Well, look, they're asking questions here. Like, what's the, you can write on your paper, like, the probability that you win both is what class? 0.16. They also want to know the probability that you get no contract. So lose both. What's that probability, friends?
0.14.
0.14. And they say, let X be the number of contracts that you get. Okay. What's the domain of the random variable X?
0, 1, 2.
You could get either 0 this is 0 contracts. If you end up here, you have 1 contract, or 2 contracts. Go ahead and set up a probability distribution table to find the probability model for X and both the expected number of contracts and the standard deviation of the number of contracts. So please do those on your own. First, if you don't mind, go ahead and the probability model is the chart. So please fill in the chart and then do that other stuff. Okay. See. Oh. Oops. So we agreed you get either 0 contracts, 1, or 2. contract, I guess you have to add the 64 and the 60 at 0.70. So how many of you have already calculated the expected value by taking 0.7 plus 0.32 to get, is it 1.02? Yes. Contracts. And then if you store that in M, 1.02 store in M, then to find the standard deviation of the number of contracts. I hope you're taking square root double left parentheses 0 minus M squared times 0.14. Plus 1 minus M quantity squared times 0.7. Plus 2 minus M quantity squared times 0.16. And those of you who typed that in, can you report to me what the standard deviation is for this thing? 0.5474 contracts. Okay, that's actually pretty good. And that's as far as we need to go on that. Yeah, good. So now, let's do our pre-yogurt day activity. So on the blank sheet of paper that you have, pre-yogurt day. Yogurt day is tomorrow, and it's not to be missed. Unless, of course, if you do miss it, then we'll have a video of it. But pre-yogurt
You're not gonna be here tomorrow?
day.
I
All right.
Are you
And
staying
this
with-
is a high stakes activity here. We have to make sure that Thursday, we honor Thursday's schedule. We got till 2:04. Friends, we have till 2:04. Here we go, yes.
I just had a question, like for the variance, when do you?
Oh,
give
did
it?
I ask for the variance?
No,
No.
but do you just give
If
it when
If
I
they
ask
ask,
for it?
only give it when they ask.
Okay.
If they ask for it, just square the standard deviation.
You don't wanna cast a wide net.
Correct. Okay, so on pre-yogurt day activities, look, I want you to know what the goals are for yogurt day. Goal 1, I want you to learn as a result of yogurt day that variances add even when we subtract random variables. This is a hard concept to learn unless you show up for yogurt day. It's very counterintuitive. Variances add even when we subtract random variables. Yogurt day will help you see why that's true, help you believe. Even when we subtract random variables. Not easy to learn. Some people go through there, they actually graduate from high school without having experienced yogurt day. The second thing I want you to learn on yogurt day is that if we use a random variable and then say this, if we play a game once, play a game twice, play a game 3 times, it's a random game. That is not the same thing. It's not the same as playing a game once and multiplying your answer by 3. X plus X plus X is not the same thing as 3X in AP statistics. And it's not an easy lesson to learn. Some people, they can't even believe it's true. They think that X plus X plus X has to be the same thing as 3X. But if you play a random game 3 times, it's not the same thing as playing it once and multiplying your answer by 3. At least not for standard deviations. It actually is for means. It is the same thing for calculated means, but not for standard deviations. And so that's a tricky lesson to learn. So that's why we're doing yogurt day. Now, some definitions. There's 2 variables we're going to use on yogurt day. So here's the 2 let statements, so we don't have to mess with this around. We want to get right to the yogurt. We're going to let X represent the amount of yogurt, not the color of the yogurt, not the temperature or the weight of the yogurt, the amount, the volume of the yogurt, the amount of yogurt in a 1 cup scoop. Now, I don't know if you've ever scooped up yogurt before, but if you take a 1 cup scoop, I'm gonna bring in a 1 cup scoop tomorrow and a 1/3 cup scoop. When you scoop up 1 cup, do you know that yogurt is gloppy? It's like, sometimes you get way more than 1 cup in the 1 cup scoop. Sometimes it's underfilled. It's hard to get exactly 1 cup of yogurt unless you smooth it off. But no, we're not gonna be smoothing it off. We're just gonna scoop up with the 1 cup scooper. And it's gonna have an expected, the average amount will be 1 cup. But it's not gonna be 1 cup every time. Sometimes it's gonna be overflowing and spilling all over the place. The standard deviation is gonna be 0.3 cups. So, I mean, sometimes it's like, it's so gloppy. That's hard to get exactly 1 cup. Now, we're also gonna have a 1/3 cup scooper. We're going to let Y represent, and we're gonna be both addings. Well, I'll have a big bowl, so we transfer the yogurt from the container into the bowl, and we're gonna try to get a certain amount, our goal will be a certain amount, and we're gonna be adding yogurt, but we're also gonna be subtracting yogurt from the bowl, and we're gonna figure out what's going on with mean and standard deviation. I thought we were gonna eat yogurt, but
Can I bring some
We're gonna have like a
granola?
parfait.
so come to Yogurt Day to find out. So, let Y represent
Not necessary.
the amount of yogurt in a 1/3 cup scooper. Is it scoop or scooper? I don't know. So it turns out that the expected value of Y, on average, you do get 1/3 of a cup. But the standard deviation of Y is 0.15 cups. This is as a result of careful study over many years, people studying, measuring the precise amount of yogurt that actually comes up in the scooper. It's turned out the average is 1/3 of the standard deviation. That's good. Is 0.15. That's not approximately, it's exactly 0.15. So, and then, so we could calculate the variance of X and the variance of Y. Like the variance of X is just 0.3 squared, the variance of Y is 0.15 squared. But class, that's as far as we went in my 5th grade class. So that completes our pre-Yogurt Day activities. So thanks for coming today, and hope to see you around Yogurt Day.